And with that, I would now like to formally begin today's conference and introduce Luke Hanna.
Hello, good morning and good afternoon, everybody. Welcome to the 6th Annex IV environmental webinar titled Marine Renewable Energy Test Centers and Environmental Effects Research. As Colin mentioned, my name is Luke Hanna. I'm a researcher with Pacific Northwest National Laboratory, and I'm going to be your moderator for today's webinars and questions. Marine renewable energy test centers around the world have been successful in testing new technologies to ensure devices perform up to standards and are able to survive in the marine environment. Test centers have also provided researchers with the opportunity to begin observing how these technologies interact with the marine environment. Programs have been developed focusing on environmental monitoring technologies and methodologies, as well as interactions between technologies and specific marine animals. This webinar will discuss current environmental effects research efforts focused on marine renewable energy test centers and what is being planned for future test centers. Next slide. So there are numerous test centers operating around the world, as many of you probably know. This map highlights just a few here in North America as well as in Europe. Today's presentation will touch on PMEC, the Pacific Marine Energy Center located on the west coast of the U.S. in Oregon and is part of the Northwest National Marine Renewable Energy Center. And we'll also discuss the European Marine Energy Center, or EMEC, located in the Orkney Islands in north of Scotland. Some other marine renewable energy test centers in North America and Europe I'd like to touch on is WETS, or the Wave Energy Test Site, which is in the Hawaiian Islands on the far left of your screen. This site is off the Kaneohe Marine Corps Base in the island of Oahu. This is a Hawaiian National Marine Renewable Energy Center and U.S. Department of Energy project in support of the U.S. Navy. There are 3 bursts at 30, 60, and 80 meters of water, and they plan to be testing point absorbers and oscillating water columns. On the other side of the U.S., there's also the Southeast National Marine Renewable Energy Center, located in southern Florida. This site is focusing on testing ocean current technologies, and they will begin with limited duration tests, eventually deploying technologies long term. Over in the north of Spain, there's also BiMEP, or the Biscay Marine Energy Platform. Next slide, please. So BiMEP is an offshore infrastructure for demonstration and testing of marine energy devices promoted by the Basque Energy Agency. BiMEC is located close to the town of Arminsa, which is in the Basque Country of northern Spain, and it consists of a 5.3 square kilometer site area between 50 and 90 meter depths, where 4 static underwater cables have been installed. On land, BiMEP also provides a research center in Arminsa where developers will be able to monitor the behavior and performance of these devices. Next slide. Another project worth calling out is the SOFIA project, which stands for Streamlining of Ocean Wave Farms Impact Assessment. This project has focused on collecting information and data on the environmental impact assessment activities being carried out at a variety of different marine renewable energy test research sites across Europe. They've developed a data management platform that has been created to provide access to information and data for many of these different test sites in research areas, such as the distance from shore, technologies being deployed, and different monitoring elements at each location. More information on the SOFIA project can be accessed from their website at sophia.eu. So with that, I think I would like to now introduce our 2 speakers for today. Next slide, please. Dr. Sarah Henkel is a benthic ecologist at Oregon State University's Hatfield Marine Science Center and director of the environmental research at Northwest National Marine Renewable Energy Center at Oregon State University. Her interests broadly address potential effects of human activities, including marine renewable energy installations, marine reserve designations, coastal development, invasive species, and climate change, all on benthic organisms. She received her BS from College of William & Mary, her master's degree from California State University, Fullerton, and her PhD from University of California, Santa Barbara. Before moving to Oregon State University, Sarah worked at the California Ocean Science Trust, working on projects related to invasive species, oil platform decommissioning, and marine protected areas. Our second speaker will be Dr. Jennifer Norris. Jennifer is a research director at EMEC. She has a varied scientific background and has been with EMEC since 2003. Jennifer has been responsible for developing the research team and strategy at EMEC and oversees all of the research projects undertaken in association with EMEC. She also oversees the EMEC consenting regime and works closely with government and Scottish and UK regulators on strategic developments in the licensing of wave and tidal devices at EMEC and in Scotland. Jennifer engages closely with the development of the new IEC certification scheme for renewables, the IEC-RE, and is one of the key players in the wave and tidal research field, representing EMEC on numerous national and international groups. And so with that, I'd like to turn it over to Sarah Hinkle.
Thank you, Luke. Thanks for getting me slides up, Colin. Okay, so today I'm going to talk to you a little bit about what we've been doing at NNMREC in support of permitting our future South Energy test site, and what we've done with a little bit of testing that's happened at our North Energy test site, and wrap things up talking about our future environmental research campaign. Next slide. So maybe these animations are going to work, Colin. Can you click and see? Here we go. So you can just click through these, Colin, because we've already went over the different test centers around the U.S. and, of course, I'm from Oregon State University. So we've got two sections of the Pacific Marine Energy Center. You can move on, Colin. That's fine. So we have what we call our North Energy Test Site. We refer to this as NET. And this is a non-grid connected site that we had permitted some years ago. And the goal is to provide a standalone electrical loading and power conversion for a test WEC and to measure and record the power output of that WEC under test. And so what you can see in the cartoon, the small cylinder in the middle would be a test WEC, and then we have our Ocean Sentinel platform, which is what provides the loading and measures the power. We transmit this data to shore. And so this is a square in the ocean that we have permitted to conduct these tests. We take the Ocean Sentinel out there when we have something under test and then bring it back in when a WEC is not being tested so that there's no permanent installation at this site in the ocean. Next slide. What we're proposing for what we'll call our South Energy Test Site would be some permanent infrastructure where we would actually have a buried cable from shore and berths offshore, more similar to the EMEC model. And we are still in the permitting process for this site, and so hopefully this is what it will look like someday in the future once we're through permitting and run cables and have multiple devices under test. You can see from the small inset map down in the corner that these two sites are relatively close to each other, just about 5 or 6 miles apart. NET is closer to shore, about 2 miles from shore in state waters, and SET is further offshore, just outside the state waters line. But they are both right outside of Newport. Next slide. So these are the sampling stations where a lot of activities that I'm going to talk about occur. And the star that's up near the top is the actual place that we would deploy the Ocean Sentinel and the device under test for NET. The larger offshore box that you see some potential cable lines running out of, somewhere in that box will be the future site of SET. You can click again, Colin, there you go, leaves that there. But what I refer to NETs and SETs in terms of environmental surveys, I am meaning all of these stations that are in the blue circle on the top. That's what I'll refer to as NETs. That's our environmental survey area, not just the tiny place where the Ocean Sentinel is deployed. And when I talk about SETs, it'll be all of those lower sampling stations, not just inside what will be the 2 square mile box that will be the installation illustrated on the previous slide. So I just wanted to make that clear that our environmental surveys are much broader than the actual boundaries of the site. Okay, next slide. So I'm first going to talk about site characterization and baseline studies that we've been doing at both NETs and SETs. then touch on the little bit of monitoring we've done of what we've deployed at NET over the past few years, and then talk about what we anticipate NNMREC's future environmental research campaign, how that might shape up. Next slide. So you see the purpose of site characterization or baseline studies, so pre-installation studies, to have 4 main goals. So Colin, you can click through these. First, we want to characterize the spatial and temporal variability in both the habitat characteristics and species distributions in the project areas. So before we can evaluate whether or not some installation or some activity is having an effect on either the habitat or some sort of biological resource, we need to understand what is the range of what might be considered normal. And so we'd look to understand seasonal variability, interannual variability, and luckily over the past few years we've even been able to survey over this regime shift from La Nina to El Nino conditions, so we can get a really good handle on what is the range of normal at these locations. And then the reason that we sample more broadly than just the square of the installation is to figure out, on this part of the coast, what is the variability across space. Next bullet. We'd also look to maybe identify some species unknown to the area. So when we do our all of our permitting paperwork, we make these lists of species we anticipate to be in the area based on the best available science. But it's also a good idea to go out there and just make some observations and see if everybody you expect to be there is there, and see if there's anyone you didn't expect to be there. Next bullet. And so once we have a good understanding of the temporal and spatial variability in these resources that we care about, this can inform the design and implementation of pre-installation and post-installation surveys. With what temporal frequency do we need to sample to potentially catch what might be an installation effect in the context of normal variability, and what is the spatial intensity of sampling might we need to do. Next bullet. And of course, these site characterization and baseline data will inform future monitoring results and adaptive management actions. Next slide. So what we've been doing at NetConcept so far are characterizing these major habitat features and species. So we look at the sediment characteristics and the macrofaunal invertebrates on the seafloor, fish and epibenthic crustaceans, Dungeness crabs, seabirds and marine mammals, ambient ocean noise, and what are the wave and current conditions. Next slide. So this is at NET. So this is at our North Energy Test Site where we will deploy the Ocean Sentinel and scaled WEC under test. You see we've been doing surveys there for quite some time. We're in our 6th year of doing surveys. So again, getting a really good handle on the temporal variability. And what I've got coded here is the blue check marks are when we had the Ocean Sentinel and the Wave Energy Technology New Zealand WEC testing at NET. It was just there for 6 short weeks. And what that involved was 2 devices moored each on a 3-point mooring. So basically you've got 6 concrete anchors there. And that'll come into play later when I talk about looking at some of the potential effects. And then the next summer, in 2013, we deployed just the Ocean Sentinel to do some of our own testing with it. And we had that out, again, for about 2 months. And then we retrieved the Ocean Sentinel and left those 3 concrete anchors in there. And so I've been conducting these surveys with these anchors in place and surface floats. And that's just a very small amount of infrastructure in the water that we've been conducting surveys around. We've got the cores, beam trawl, bird observations, marine mammal observations. We had a seafloor hydrophone, that's the acoustic lander. We did some surface hydrophone surveys while we had devices in the water. You can see characterizing surface waves with a triaxis and characterizing bottom waves and currents with an AWAC. Next slide. And then we've been conducting similar surveys for the past, we're in our third year at PMEC sets. And so when we started the permitting process for sets in 2013, we started conducting similar kinds of surveys. We've been pretty successful with everything except our seafloor hydrophone. We deployed 2 last year. 1 was recovered with heavy damage, and 1 was never recovered, but we put a new one out in June, so we hope to get some ambient ocean noise data from sets in the near future. Next slide. So just to give you a little peek more at what all those check marks mean, when we sample the sediment in the macrofauna, we use a 0.1 meter squared box core, and we sieve the collection through 1 millimeter mesh sieve to collect all the organisms. We also take a sediment subsample for grain size and total organic carbon. And we can see if there are any grain size changes associated with having devices anchors really on the seafloor. Next slide. So what you can see from this chart is with 5 years of sampling that the sediment is pretty stable, the sediment characteristics. So this is median grain size. The blue line is from our 30-meter sampling stations, and you've got smaller median grain size there, but very consistent. And then at 40 and 50 meters, the grain size is larger and pretty stable at 40 and slightly more variable at 50, but not significantly so. And then we deploy the Ocean Sentinel and potentially a WEC under test. That is deployed around 45 or 46 meters. And so that's really great for our sampling regime because it falls right in between 40 and 50 where there's overlap in the grain sizes. And so if there were any differences around the anchors from either 40-meter stations or 50-meter stations, that'd become apparent pretty quickly. Next slide. And so the macrofaunal invertebrates, they actually have really strong spatial heterogeneity, but this has been extremely stable over time. And so all of the 30-meter stations have very similar communities there. The southern 40-meter stations are similar to each other and fairly similar to 30. Then you can see this yellow diagonal lasso where the northern 40-meter stations are more similar to the southern 50-meter stations, and then the northern 50-meter stations are unique. And this is what you might consider a cumulative effects kind of scenario, where those southern 40-meter stations are bracketing the dredge spoils, dredge material disposal location from Yaquina Bay. And so they're getting periodically an influx of smaller grain size sediment from the bay, which is probably what makes them more similar to the 30-meter stations. And so when I get to talking about looking at detecting device effects, I'll primarily talk to you about comparing the net data to those northern stations, northern reference stations, because I wouldn't want to be trying to compare back effects to dredged spoils locations. Next slide. When we do the epifaunal or fish sampling, we use a 2-meter wide beam trawl, which we tow along the bottom. And occasionally we have it outfitted with a camera, as you can see pictured here. But primarily what we get are flatfish. And we also look at mysid shrimp, crayon shrimp. We get crabs, we get sea slugs, and some summers we get gallons and gallons of ctenophores, which is what you can see on the upper right. And those are pretty frustrating tows. Next slide. And what we found with the fish is that kind of the opposite of what we found with the macrofauna. So the fish species are varying across seasons, but not spatially. So there's no depth variability and no difference from the northern and the southern stations. So basically we've got a pretty strong summer cluster, sort of a fall transitionary cluster, and then a winter cluster when you do a community analysis. Next slide. We've been looking at Dungeness crab distributions since we started sampling at SETS, the South Energy Test Site. They're a very high value species here in Oregon, both ecologically, economically, culturally, and so people have raised concerns about them. So what we've been doing is looking at CPUE inside the SETS area, shallower than the SETS area, and in locations north and south. And so if you click Colin, basically what we found is the CPUE varies by depth but not by transect. So we always get more crabs at our shallower stations than our deeper stations, and our deeper stations are within the SET spots. But there's no difference at the SETS location from reference areas north or south of there. So SETS doesn't seem to be a particular hot spot or place where crabs avoid. Next slide. In terms of seabird or marine mammal observations, these are conducted in a variety of ways. So anytime that we go out on a box coring, trawling, or crabbing cruise, we have marine mammal and seabird observers aboard. And then when other NOAA researchers go out using our vessel, those observers go along too. And so for this is basically confirming the species that we think are there, looking to make sure that we know all the species that are potentially in the project area, and trying to get a little bit of handle on seasonality to see if there are times of year that are better or perhaps we should avoid for certain construction activities. And what you can see from the line chart is that different groups of birds do have different times of year where they're most abundant. So the diving piscivores are most abundant in the spring, where the surface planktivores, there we see more of them in the summer months. In terms of the marine mammals, this really is a look-see effort. We really can't see enough to do any statistics on them. You can see that in 3 years of sampling, we've seen 145 marine mammals total. So the only thing that's even really worth making a chart about are harbor porpoise. And so that's something that potentially could be something that we would add to the research agenda that I'll talk about at the end, because that's something we really might be able to gather enough data on to ask interesting research questions. Next slide. And finally, when I talk about acoustics, this is just a picture of one of our types of landers that we're not using anymore now that we've lost a couple of them. But basically, you've got a frame, you've got some hydrophones, and then you've got a pop-up recovery system. And we leave these out from 3 to 5 months, bring them back up, change the batteries, and put them back down to characterize the ambient ocean conditions. Next slide. And what we found from the 13-month deployment up at NET is that the dominant sounds are weather-related, so wind and waves, and ship noise. And what this spectrogram is showing you, the top one, they're both the same time period. The bottom panel is just the bottom 200 hertz of the top panel zoomed in. And basically what it's showing you is that you can see the red and yellow intensities are when we get winter storms, and also the last half of the panel from December to April is when we have the most ship traffic, because that's our crabbing season. And so on this, you can just see when the loud times are. But Colin, if you zoom in really close, you can see the difference between what anthropogenic sounds like ship noise, or click again, Colin. And that's what marine mammal acoustic signature would look like. So when you zoom in on the specific intense bands, then you can determine what is making that noise. Next slide. So real quickly, I'm going to go through detecting device effects because we've only had a few things in the water for very short periods of time. So go ahead, Colin. So do we detect acoustic effects? When we had the WET&V and Ocean Sentinel out in 2012, we were able to detect some sound energy that appeared to be transmitted by the devices. However, in that deployment, the hydrophones we were using were actually attached to the boat. The boat was free drifting, but the hydrophones were attached to it. And so we could hear a lot of water slap on the hull of the vessel and noise from the boat itself. And so it was really hard to characterize anything about the sound that we might have gotten from those devices. But although we couldn't characterize it very well, it still remained well below the NNMREC threshold criteria of 120 decibels. In 2013, when we had the Ocean Sentinel out by itself, we allowed the hydrophones to completely freely drift, so let them go from the vessel drifts away, hydrophones go by to installation, and then we circle around and pick them up later. And we were able to detect the sounds of the mooring hardware, so chain noise, at 5 different spectral peaks, but this was, again, still far, far below the NNMREC threshold criteria. Next slide. In terms of the seafloor, when the WET&V device was out there, we did one ROV survey, and you can see some scour around at the bottom of the anchor. From the picture in the lower right, you can see sediment missing from below the anchor and some shell hash around the anchor. And in our box scores, up until that point, we hadn't collected large amounts of broken shell. And so when we saw that, that was pretty interesting to us. So next slide. In 2013, when we had the anchors out from the Ocean Sentinel, we started doing box scores as close as possible to the anchors. Now, this is something that's been a great opportunity where we brought the Ocean Sentinel in, but left the anchors out. And so we can approach the anchors very closely with our box score without worrying about getting caught up in mooring lines or electrical cables. This is a really neat opportunity. So what we do is we use a rangefinder, like you would use if you were out hunting, and train it on that surface float, which is connected to the anchor at the bottom, to estimate our different distance away from the anchor. Now, it's not perfect because there's a watch circle, of course, for that buoy. We don't know exactly where we are in relation to the anchor, but we take 4 grabs away around the anchor, and then we take some going from the anchor east, which would be shoreward, which where we would expect maybe more effects, and then we take them from the offshore anchor going offshore, where we might expect less effects. So next slide. And what you can see, so this is a plot of the proportion of shell hash or gravel in the grabs, which is something we, like I said, typically see very little of, very little gravel, very little broken shells in our normal cores. And it's 1 year of data. In the back of the chart is October 2013. That was our first sampling. So about 2 months after the anchors went in, through October of 2014. And with the purple bars in the back, the first time we went out, we didn't think about going offshore. We just sampled from the anchor inshore. You can see there was a huge amount of shell hash, which was consistent with what we've seen on the ROV video, compared to what you would normally see at the reference stations, so 30, 40, 50, and 60 meters. And so that was shortly after the installation during a quiescent summer. And then we didn't go out over the winter, and when we came back in April of 2014, the proportion of shell hash had greatly decreased around the anchors, shoreward of the anchors, and then you can see OS West, which stands for Ocean Sentinel headed west. There's very little shell hash, and it had decreased even again by June. And then it looks like similarly to the first year, after the quiescent summer where we don't have a lot of wave activity, the shell hash started accumulating again around the anchors. And then we have very little data from October 2014 because that's when the ocean picked up again. And we just got out there and grabbed around from the anchor shoreward and at our 40-meter reference stations before we got our butts kicked and had to go back home. And but there's very little shell hash that's accumulated, presumably because the ocean has stirred up quite a bit. And so you can see definitely some changes in the seafloor related to the anchors, probably seasonally influenced. But what you don't see is changes to the actual grain size of the underlying sediment. So if we sieve out all of the gravel and chunks of shell and then analyze the sediment that remains, that grain size has not changed significantly. Next slide, Colin. So are there effects on organisms? So there's a lot of points on this MDS plot, but the take-home message here is the yellow triangles that say they're from 45 meters. Those are the box cores from around the anchors. The green ones are the 30-meter stations, which are distinct, as I told you before. The blue triangles are 40 meters, some of which are similar to 30-meter stations in the south, as I told you before, and some of which are more similar to 50-meter stations, which you can see more on the right-hand side of the graph, overlapping with the blue 50-meter squares. And those, the macrofaunal organisms from around the anchors are just falling right in there at the interface of those 40-meter points and those 50-meter points. So while we are seeing some accumulation of gravel and shell hash around the anchors, it does not look like we're seeing any changes to the organisms that are living in that sediment. Next slide. When we look at some of the epifaunal crustaceans, particularly I pulled out here the Kringon shrimp, don't see any changes in their patterns of biomass associated with either installation. I got highlighted in purple when we had two devices in the water, the Ocean Sentinel and the WEC under test, and in orange where we had the Ocean Sentinel and its anchors, and then subsequently the anchors only, and we don't see any significant variability in the epifaunal crustaceans, so no changes there. Next slide. And in terms of fish, we've definitely seen over time some changes in the number of flatfish that we've been catching, and these are at our reference stations. We don't take the trawl net too close to the anchors. And we have seen more flatfish in recent years than before, but we think this is primarily related to the El Nino conditions we've been experiencing in 2013 and 2014, because you can see there was no change in benthic fish density during the wet NV deployment, and the recent increases started in April of 2013, long before the Ocean Sentinel installation. So we don't see any effects, at least on the soft sediment fish community associated with these devices being in the water. Next slide. Can you click it one more time, Colin? Maybe my heading. There we go. So basically, this is just sort of the information, site characterization, baseline data that we've been collecting for these two sites. Once we get the sites permitted, and once we actually get devices to test at these places, then we'll be able to look into some interesting research questions, actually coming up with hypotheses and testing them with structure in the water. And so the way we see this playing out is that we'll work with the research agencies to determine what are the most interesting and important environmental research questions about marine renewables that we can address at PMEC. So in a place where you're going to have, very slow phased installation, 1 to maybe 4 devices at a time, in order to develop a prioritized research agenda for NNMREC, for the Renewable Energy Centers here at OSU. And this is not necessarily something that will be carried out all by NNMREC scientists, but we want to make sure that we've got a research agenda for PMEC so that if there are other scientists interested in conducting research at PMEC, that their activities align with these priority issues that NNMREC has worked out with the agencies. It'll enable us to communicate with DOE or other funding streams. What are some of the priority research questions that maybe they'll include in future funding calls? And then as we get devices tested and conduct research, we'll evaluate this agenda periodically to see what goals are being met, what might no longer be a priority research question due to activities in other places like at WETS or at EMEC, and then what new topics should be added to the research agenda. So we are really just in the phase of gathering information, and we look forward to being able to conduct research once we have devices to conduct research on. So that concludes my part, and I think we'll do questions at the end of everything, Luke.
It looks as though we have a couple questions right now, so we can ask those, and then we can do kind of a longer question and answer session at the end of both presentations, if that works for you.
Yeah, I can take some now.
Okay. So are there any other devices planned to be tested at the sites you mentioned in the near future? And will the sampling regime you discussed continue with the next device? I think you kind of touched on that, but...
So right now, there's nobody on deck, so to speak, to test. NET is available if there are any developers out there who are looking for an opportunity for scaled testing. We don't have anyone on the docket. SET has not even yet been permitted. We're still in the permitting phases of that. So it'll be quite some time as we go through the permitting process and then lay the cable before we'll be open for business, so to speak, for developers to come.
Gotcha. Okay. And then you also mentioned looking into future research questions once you get some other devices in the water. Are there any other research questions that you see at this point being particularly pertinent or of special interest of NNMREC or other natural resource agencies?
Well, there's lots of questions out there. One of the things that we've talked a lot about are, what are maybe some of the nuances of the artificial reef effect. We're pretty certain that these are going to be an artificial reef. You put structure in the water. Fish that are attracted to structure get attracted. Right. But, there's an opportunity here for someone who, maybe has spent a lifetime looking at artificial reefs to see, what shapes of devices, what materials could result in different kinds of attraction of different species. What does it look like when you have phased installations where more structure is added over time? That's not typically been the way an artificial reef has been built. So, if there were a researcher who was very interested in the nuances of artificial reef building, PMEC would be a really great place to conduct that kind of research.
Definitely. And then one more that just came in. If you know trends in benthic communities and fish you're sampling, how do you determine whether the change is beneficial or harmful?
That's a really great question. And, that really depends on the magnitude, and it also depends on your perspective. One of the things we've talked about is if you are a crab fisherman, installation with a lot of structure that you can't drop crab pots in, regardless of what the perceived ecological effects might be, is going to be seen as negative. If you are a rockfish fisherman and this becomes an artificial reef and attracts rockfish, and you may not be able to go inside, but you can fish the boundary like we see people do with marine reserves, this could be a very positive change because now you've created a fishing opportunity for that sector. So it definitely depends on, with what resource does your heart lie, I would say, whether or not it's a positive or negative effect.
Right. Yeah, that is definitely it's definitely an interesting question. And then finally, what level of change in benthic habitats and communities do you expect is needed to be able to relate those changes or not to the presence of a WEC? And what level of sampling effort do you think will be needed to follow those changes, or one or more WECs are in the water, or after one or more WECs are in the water?
Right. So that's one of our definitely a question that we're very interested, or I'm very interested. I'm director of all the environmental research that happens at NNMREC, but I am a benthic ecologist. And so what's been really interesting with the anchor sampling that we've been doing so far, just around the anchors that are there, and again, it may be an artifact of not knowing exactly where you are in relation to the anchor, but sometimes it's our station that's 10 meters away from the anchor where we see the most shell hash, and sometimes when we go out, it's our station 250 meters away that has the most shell hash, and our closer stations, we don't see any shell hash. And so that's been really interesting. The bars I showed you were an average of all the stations, but it's been pretty variable each time we go out, where in relation to the anchor do we see this accumulation of shell hash. Now, the flip side of that is, although we've seen this accumulation of shell hash and a lot of variability in where or what time of year we see the most of it, we haven't seen the macrofaunal assemblages differ from the reference stations. So, does that accumulation of shell hash and its extreme variability make a difference to the organisms that are living there? And, to date, we don't have evidence that we're seeing an effect. Now, when we get multiple devices, and perhaps with overlapping spheres of influence, we might be able to detect some changes. But I think that is so my perspective would be, from a monitoring situation, we're not seeing differences in the organisms. And so we can say we're not seeing differences in the organisms. If you're looking for an interesting research question for a grad student to conduct their thesis on, looking at really fine scale details about the macrofaunal assemblage and how those might relate to the distance from the anchors and the sediment characteristics. Now that could be an interesting research question for someone to look into really closely.
Definitely. Okay, great. Well, thank you. I'm not seeing, one just came in. What do you think is an appropriate time to develop a confident baseline?
So I think we have definitely done it with 6 years. I think that's probably more than you'd ever get a developer to do. We've just had that opportunity only because we haven't had people testing it NETs. If we had developers testing it NETs, we would have only had 3 years of baseline because we would have had a lot more activity. I think, as a scientist, we've been told, never measure something twice, right? Because you don't know which is the right answer. So right. You want to get 3, so you've got an average. That would be my scientist perspective. If I were a developer, I might balk at that. And so I'd say a minimum of 2, just so that you at least do have some handle on the variability. I think it would be risky to just do 1 year of baseline because then you would have no idea of the variability. And if your installation showed differences from your 1 year of baseline, you'd really have no idea whether that was an installation effect or part of the natural variability of the system.
Right. Okay, and then one last one, and then we'll move on to Jennifer. Are people out there working on biofouling or biosecurity aspects of devices and moorings?
A little bit. So we've had OSU researchers, grad students, have been engaged in looking at alternative methods of preventing biofouling. So, preventing biofouling is its own large industry. There's a lot of ship manufacturers and biofouling paint companies who spend a lot of research and money on that. But OSU researchers have been looking at some novel ways of preventing biofouling using energy from the device to sort of put a charge across the surface. So that's, early phases kind of research question. And then I've got a grad student who will be looking to pull the ocean sentinel anchors later this summer. And so we'll be looking at, after 2 years, what's been growing on the anchors on the bottom versus what's been growing on the steel floats at the top. So sort of different places in the water column, different materials, the different kinds of biofouling you're going to get there.
Okay. Great. Well, thank you very much, Sarah. I think we should probably move on to Jennifer's presentation. I did see one hand raised, so I think there are some other questions. If you do have other questions, please just hold them till after Jennifer's presentation. And with that, I'd like to introduce Jennifer Norris.
Thank you very much. So thanks very much for the invitation to speak today. It's going to be a rather different talk to Sarah's. I tried to condense really all the most relevant points really into the sort of summaries of findings, approaches and findings taken at EMEC. So I'm going to be talking really about the sort of main sensitivities, the environmental sensitivities that apply at EMEC, and some of the approaches that the developers and EMEC have taken, some of the researchers have taken to try and address some of the regulatory queries. So I wanted just to remind people of where we are. We are in Orkney, as was said at the beginning. We have our full-scale wave site off at Billiacrew Bay, which experiences the full Atlantic fetch, and that has 5 cables, 5 grid-connected berths, which are available for testing of wave devices. We've got at our Fall of Warness tidal site off of the Northern Isle of Edy, we have our 7 grid-connected cables up at our full-scale tidal site there, and in 2010 we developed 2 scale tidal and wave sites in more benign conditions, and these are not grid-connected sites, but they do provide mooring blocks for developers to come and attach to. And in relation to one of the questions about reef effects and studying foundations, it's relevant to say that when we designed those mooring blocks, we did design them specifically with refuge areas in them so that they would be available for subsequent studies for any artificial reef effects or for recruitment studies of lobsters. And so those are available for either short-term or small-scale testing of devices. We have one office which is in Stromness, and we are based right above Heriot-Watt, the ICIT, International Centre for Iron Technology. We also have a number of units that we rent out to developers who all need space, of course, to work in. And we have a very supportive local council and harbours department who have sort of moved with the times and built up peer services and facilities for the developers as they come along. And there's an excellent supply chain within Orkney, which was really one of the factors taken into consideration in locating us here. So that's really all I'm going to say about EMEC in general, because I think most people are aware that we're a test site. The only other things I am going to say is to point out that I suppose a key difference really between ourselves and some of the other sites is that whilst we were developed with government funding initially back in 2002, we are actually a private not-for-profit limited company. And as such, we have to raise specific project funding for all of the environmental monitoring that happens at sites in a generic fashion. and we, if you like, we're between a rock and a hard place to some extent, because we're not eligible for most of the academic funding, even though a lot of the issues that require addressing are academic, and nor are we a developer ourselves with investment funding for development of devices. So we straddle that difficult area in the middle. And I have to say, we have suffered from not being able to raise sufficient funding to make the best opportunity of what we have at the sites, but we've done our best. So what I wanted to talk about really now is addressing the main environmental risks that apply to the species at the sites that we operate at EMEC. This is not by any means an attempt to address the wider scale of devices that apply to the whole sector. We'd be here all night and beyond probably if we were aiming to do that. So I've really centred on the issues that are of main concern for the regulators in providing licenses to the developers to deploy their devices at our sites. And there are really four main issues. I have to say they largely apply to tidal devices, although some of them apply to both wave and tidal. So you'll see up there, if you like, I suppose, issue of concern number 1 for tidal, which is the issue of potential for collision between susceptible species and tidal devices. That's probably issue of concern number 1 from our perspective, partly in terms of the difficulties of gathering data, which I'll come on to later, but partly because of the state of development of the tidal sector at the moment, and the fact that there are array sites being licensed at the moment for which monitoring is urgently needed. The second issue is the potential for displacement of marine wildlife from habitual waters, and that applies both to wave and tidal devices. And I'll be talking about some of the projects that are in place later on. Apologies for this, the animation on there, but I'll just go through them. So the potential for noise emissions from devices in operation, this is, to cause either harm or displacement of key species from their habitual waters is probably issue number 2 for us. And again, both applies to both tidal devices and wave devices. Moving on then, particularly our wave site, but also our tidal site, actually, these are sites that were placed in fairly shallow waters, so they're both maximum depth 50 meters, and they have been used in the past by commercial fisheries. So our wave site has been used in the past by creelers, crustacean fishermen, and the tidal site has been used by scallop divers. So these are, in operating our sites, we have sought very specifically not to try and introduce them as closed areas or to get whatever levels of protection are possible to get them as closed and inaccessible areas. We've tried to make a point really of ensuring the cooperative use of seas by all sea users as far as possible. And so we do recognise that the fishermen did used to fish in the area that we currently use for our wave site at Billiacrew, and we have put in place, we did finally manage to get some funding for a project that sought to have a dual socio-economic and a scientific basis. I'll speak a little bit about that later on. And navigation and safety, that's just up there to really remind people that the issues of concern from a regulatory point of view are not just the environmental risks, and there's a strong interplay between issues relating to navigational safety and some of the environmental risks as well. But I shan't be talking any more about the navigational issues. So really that's to capture that the main sensitivities on our tidal site in relation to the concerns about potential for collision causing that may cause damage really relate to the range of marine mammals and diving birds that frequent our tidal site. The issue of displacement, the approach that we've taken to data gathering there has has been one of gathering large data sets over the years. Since 2005, the initial project was established, gathering 20 hours a week in 4-hour watches of land-based observations using binocular telescopes and recording all the surface visible sightings to species level wherever possible. And so the two grids shown to the left of the stalwart observer there are on the upper one is the grid that was developed for recording all the sightings at our tidal site. And then when we developed the approach for the wave site, there was no end point against which to gauge the specific location, so it's much more difficult to develop a matrix approach. So we worked with some expert parties to develop a protocol that used a radial recording approach, where you basically record the angles of the sightings and work out the locations of each sighting from there. So we've got large data sets that actually are currently the subject of a wide data analysis project that I'll talk again a little bit more in a minute. So the other large issue of significant concern is whether or not there's any potential for either displacement or physical harm to the hearing organs of sensitive fish and mammals. You'll see there the overlaps, clear overlaps between the noises, the anthropogenic caused noise and the hearing ranges of fish and mammals. It's probably no news to any of you. I'm not going to talk in detail. In my first version of this presentation, which was rather longer, I did have slides relating to all the detailed monitoring that we've done, including background studies, but those are available on our website. For purposes of brevity, I removed them again from this one, but I'm happy to take questions at the end. So basically just capturing that is one of the issues of concern that relates to the devices deployed at the EMEC sites. And then again, the socioeconomic impact. We really mustn't forget that range of impacts, because as we see devices develop, and certainly as we see the licenses awarded now to the wider, larger commercial array sites, these issues are becoming very important indeed. So needing to bear in mind approaches taken to shipping and tourism and leisure, but of course primarily of concern are any effects on reduction of areas available for commercial fisheries. And to pick up on a point earlier, I mean such effects could in fact be beneficial. And whenever we're talking about effects here, I think it's important to realise that effects could be beneficial as well as negative. I think we can tend to forget that sometimes. So again, the picture down below shows a lobster, fairly obviously, and refers to a project that we established with working with the local fishermen to grow on a number of lobster to a larger stage than normal in the hatchery, and then to tag them and get them released at our. So again, I'll talk a little bit more about that in a minute. So those are the main issues that developers coming to EMEC who have to obtain licenses to deploy their devices, they have to address those issues in their license applications, and they have to introduce mitigation, of course. And I think the reason why all of you will be listening is that you realise that it's very difficult to even properly and adequately assess the environmental risks when there's very little evidence base available to allow the risks to be properly assessed. So I've mentioned here in this slide clear methods that various people use to try and assess the potential risks using encounter rate models for potential collisions and a range of other models to predict effects on a range of other issues. But basically the point I wanted to make in this slide is that there is a dearth of evidence, there's a real lack of evidence, and we need to take all opportunities that we possibly can to gather evidence, to build up the evidence base that then developers can use in their risk assessments as they progress. And the approach that's been taken here in Scotland, again, probably no news to many of you, is that's been developed between Marine Scotland and Scottish Natural Heritage and has had input from EMEC along the way, is to recognise that there is not the necessary evidence base and to introduce what they call a plan, deploy and monitor approach to licensing. So that recognises that where there is no evidence base, then it is incumbent on the first stage developers to put in place monitoring that they can work through in an adaptive fashion with the regulator to try and gather the information that's necessary. And that's where we come on to the problems, really, because data gathering by monitoring devices that are operating in situ under the water has a lot of different challenges. And I've captured just a few of those challenges in different categories here. So you need to bear in mind the conditions that are pertaining at the sites. You're looking at gathering data from under the water with limited daylight hours in some seasons, with difficult weather conditions, which can make the deployment of data gathering equipment difficult. It can make the retrieval of data gathering equipment difficult. As Sarah mentioned, data gathering equipment can be lost on occasion. There can be low light levels. You can get biofouling of lenses and other equipment that's aiming at gathering data. And if you're dealing with monitoring in a tidal site, obviously you have, in our case, you have up to 7-8 knots tearing down the test site, and that's quite a different resource into which to try and place monitoring devices. So you have to bear in mind that anything that might have a surface presence, whether be it a buoy or be it a data transmission, be it a locational buoy or a data transmission buoy, everything will tend to get pulled down under the water as the tidal state varies, and thereby become a navigational hazard potentially. So a lot of practicality issues also related to the availability of vessels. So every piece of data gathering equipment that needs to be deployed in the sea is going to be costly, very costly, when you have to take into account contingency costs for delayed activities and postponed activities that are suddenly called off due to weather changes. All these costs need to be fed into proposals for data gathering, and can actually, in our case, we've had a lot of experience of proposals for data gathering that have initially been received with enthusiasm, but actually once the full costs are appreciated, they can prove very difficult to fund. So the deployment methods can be challenging, and again, that's where EMEC has a lot of experience in putting the equipment out and actually getting it to stay there and retrieving it. But it's no simple matter. And getting nighttime coverage, it's all very well, as I was saying, about getting the daylight species information gathered from using telescopes and binoculars, but gathering nighttime data is equally important, but equally challenging, even more challenging. So then to summarise some of the technical problems that we have to deal with is that there might even be disturbance caused by some of the sensors that are used to try and gather some of the data. So, for example, where people are trying to use active sonar devices to gather data in relation to the concerns about collision. There's a lot of concern about whether or not those sensors actually cause disturbance in their own right due to the frequencies that need to be used. The availability of commercial off-the-shelf sensors. There are sensors available, but they tend to have been produced not for the purposes for which they are being used in these projects, and they can often actually prove inadequate for the purposes that they're used for, and end up being unable to provide the information that everybody's hoping they can provide. We also need to think about the huge impact of the data retrieval and storage costs. So how is data going to be retrieved? If you're going to put a sensor out in the sea, are you going to put a massive battery pack along with it and then go and retrieve it after a couple of weeks? Or are you going to cable it, which has its own problems and challenges? And then once you've actually managed to get it back to the office or whatever storage area, then especially if you're dealing with acoustic data, you have masses of storage to deal with and data interpretation to deal with. So even once you've got the data back, then actually interpreting the data to try and address some of these issues and provide answers is very, very challenging in its own right. So here I wanted to just summarize really some of the approaches that have been taken by the various developers and some of the research that has gone on at the EMEC sites to try and address these issues. The regulators in Scotland have not really had it, have not had any best practice methods to call on really, because it's too early within the sector to have best practice methods developed. And so the regulators pretty much have to leave the developers to their own devices, and the developers have to go away, scratch their heads and say, well, what data am I going to collect to try and inform on these issues of concern? So no surprise to see that people have tried deploying cameras and getting underwater video. And some of the challenges we've found there are basically the time taken to analyze 24/7 video coverage, and also the gathering of the data in the first place. That has to be catered into the design and the cabling, cabled back. But the time taken to analyze 24/7 video is phenomenal, obviously. Some of the problems that have applied over the years to some of the camera deployments, they tend to have been biofouled. They tend to not really be able to be used at long enough distances away from devices to provide any useful data. Some of the developers have looked at using strain gauges within the tidal blades to try and detect collision events, which in theory is a laudable approach. However, what we've seen from those reports that have come back is that really the level of information that you get back is not really of a useful granularity. So what would need to be done would be some automatic processing of the data to try and discern between the different types of signals that might be produced in the gauges that might indicate whether or not the impact had been caused by a hard body, a soft body, a large body, a small body, an animate body, and indeed, even if you could discern those from one another, could you distinguish them from disturbances within the tidal flow, from turbulence within the water column? So there's not much evidence yet that using that approach has yet been able to provide any sensible, useful information in regard to the concerns about environmental risks, which is not the same as saying that they're not useful for other purposes, condition monitoring, detection of collision events, or other purposes. Some developers have deployed internal hydrophones to try and basically listen for any impact events. And again, similar problems. It's all very well identifying an impact event, but then when you have to attribute the event to a body of a certain kind, that's what you really need to do. And again, even if you can do that, then that's only the first stage in trying to decide whether or not that impact event had any effect on whatever it was that might have collided. So there have been other attempts to use active sonar to effectively visualize objects passing through the field of view in the vicinity of tidal turbines. And I think you'll probably be familiar with the Flowbeck project. I think Beth is on the call. who might be able to answer questions later. And also EMEC, at EMEC we have our own active sonar device that we've actually deployed in the water, although we are still looking for funding to do a proper analysis. But the point being that people are looking at using active sonar to almost to replace what the kind of information they would be able to get from cameras if cameras would work at the distances that are needed. And I think what's become clear in respect of the issue of collision is that there really is a need for an integrated approach that perhaps uses multiple data sources, and it seems likely that there is going to be no one answer, no one kind of data stream that is going to provide the regulators the information that is really needed to address their concerns. So in terms of displacement then, as I mentioned, we've had in place land-based visual observations for, we've got long-term data sets. The Fall of Warness data set was begun in 2005, and in 2010 we finally managed to get funding for the Billy Crew wave site project. And so ever since the beginning of those, they've been funded. Marine Scotland have been very good at funding 20 hours a week of observations. And then last year we managed to get funding for a project to analyse the full data sets, which was great news. And that project is underway. We're doing work with CREAM, the Centre of Research into Ecological and Environmental Modelling, based in St Andrews. So we're doing a project that is due to end in 2015, looking at all the data that we've collected and seeing if there's any evidence for any displacement having occurred, and looking at predicting the likelihood of such displacement occurring in future. Now I have to say all the data collected are available from the Marine Scotland website, and if anybody's after it and can't find it, then do drop me. So noise emissions then, back in probably 2005, I think some of the developers were looking at how they would address these concerns about noise emissions from their devices. And I think Sarah's touched on some of the issues that relate to gathering data from the marine environment. You have to be very careful not to be overpowered with flow noise. So hanging a hydrophone off of the edge of a boat isn't really a very robust method. You tend to get reflections from the boat itself, from the hull itself, which can vary depending on the material of the hull. The approach that we've taken is at EMEC is to develop drifters that we deploy at the top of the tidal site, and we allow to drift down through the water column. So that's a hydrophone deployed within a drogue. Again, on our website, we have more photos of all these methods, which I haven't put on this presentation really for brevity. But basically, we got a couple of funding successes to enable us to get some background data levels, sound data levels recorded, and those data are available. But really, as we've progressed, then the developers, the range of developers have taken their own, have used the opportunities to develop their own methods of gathering data in order to try and estimate to try and characterise the sounds that their devices have produced. What we have seen as we've worked with Marine Scotland to look at the outputs of those reports is that they tend to be there's a lack of consistency, and some of them tend not to be so robust, and there's a real need for more consistent studies of devices in operation. So the learning, unfortunately, out of the sort of amount of noise emission studies that have been done has basically been a recommendation that there should be more consistency used and better guidelines for doing that. And I know, so we were involved in doing a piece of work with the UK regulators and various acoustic experts to try and provide a guidance document for regulators and for developers on what to look for and what to do in your acoustic studies, and those are available. That's available from our website as well. But really wanted to highlight there the difficulty when there are no best practice methods, the difficulty that developers find themselves in, and to reiterate really to other test sites that are developing at the moment the need for good funding to be in place right at the outset to enable these things to be done well from the outset. And then the final one is the inshore fisheries. We put in place the lobster study, which we worked up with the fishermen, aiming to work with the fishermen in gathering the data. We did see tagged juveniles deployed, released at our wave site. We worked very in close liaison with, we subcontracted ICIT, in fact, Heriot Watt, to do that study with us, and we worked closely with the fishermen. And the local fishing society has managed to get funding to continue that study, which is excellent news. So the point of this slide is to show really what I've touched on so far, which is the vehicle that we have at EMEC for looking at the efficiency, the efficacy, and success of any and all of the data gathering and the environmental monitoring that's been undertaken at the EMEC sites. So this group, the EMEC Monitoring Advisory Group, is one that has formed many years ago, which sees us liaising very closely with the regulators in Scotland and all their environmental advisors, particularly Scottish Natural Heritage and the Sea Mammal Research Unit. We've looked throughout at addressing uncertainties from the regulatory process, because the onus has been on really enabling devices to become licensed and get in the water. That's been the focus throughout. Whilst we recognise there are very, very many interesting research issues that can be addressed, our primary focus has been enabling the licensing. So we've been looking at what monitoring could be undertaken generically then at EMEC and what could be learnt from what's been done. So the pound sign is there for a very good reason, again as a reminder to people to adequately resource their research and monitoring programs. It's very, very frustrating to try and develop a program as we've done at EMEC, which has had no funding from the outset and has to be funded piecemeal in a very limited funding scenario. And so then the opportunity we really did take was to review all the developers' projects as they'd come in, looking at which methods used and which didn't, as I've touched. It also allowed us to review all the other research that's been undertaken, and so we had we've looked for the learning effectively that has been gained from some of the projects that you'll have heard of, the Flowback project, the Response project, that you can look up on the different websites to see the findings of, and also then looking at gaps that we have for the future, for future monitoring that will benefit the industry as a whole, whilst continuing to enable more eased regulation. And it's, I suppose the overall finding, which is not what everyone wants to hear, but it's honest, is that current methods that are being used, they do provide some evidence that's needed. So we are seeing some very good work coming out of the analysis in the Flowback project. Again, have a look at that website, looking at using the EK60 fish finder as the active sonar and doing some other very good studies with radar. So there are pockets of success coming out, but from what the developers have actually been able to use themselves in terms of the off-the-shelf sensors that are available, there's recognition that the sensors are not really good enough, but do show some potential for improvement. So really the approach that we took back in 2010 with a project called the REDAPT project, which was funded by the Energy Technologies Institute, was to recognize that an integrated approach was almost certainly needed to data gathering, and that no one main data set was likely to give all to address all the issues of concern. We recognized the main environmental concerns are as stated, and again the main challenge here was to gather data from what is a very complex environment indeed, where really the data sets that you need to gather are so long. To have prolonged data sets gathered in the vicinity of devices requires either massive battery packs or cabling, and so we took the opportunity to develop a cable system. And the next slide shows the overall approach that we've taken. So we built, I suppose this was a precursor, I suppose, to the Flowbeck pod and other pods that have developed since. So we built a multi-sensor seabed pod which has active sonar. It has a current profiler. It has 2 hydrophones pointing in different directions. Actually, they're shown in pointing in the same direction for graphic simplicity there, and a CCDU unit there. That's the actual pod as it was deployed in 2012. I would just add that after it was deployed and commissioned and all the data was successfully retrieved from it, we had a problem with one of the connectors and to the power unit, and unfortunately we had a corrosion pathway set up, so we had to retrieve the unit, and then the funding ran out for that project, so we then spent another 6 to 9 months raising further funding to get it further developed, which we've now successfully done thanks to the Scottish Government, the Carbon Trust, and we have created a more flexible unit which will allow us to swap out the sensors, so we can put on a different active sonar device. We could swap out the hydrophones, and we could put other sensors on as well. It is a cabled system, so it is much more expensive to deploy than a non-cabled system, clearly. But it is in the water as I speak. It's gathering data from the hydrophones, the active sonar, the ADCP, and it's incredibly frustrating for me to have to admit this, but one of the things that we have still not been able to raise funding for is the development of a properly integrated data analysis approach, which funds the vast amount of data analysis that's needed. That's something we're working on right at the moment, and we hope to get some success. So in a little bit more detail, just coming towards the end now. So that's the unit. When it was deployed, first of all, it was deployed 100 meters away from the turbine. So here's the pod. I don't know if you can see the cursor on the screen. It's 100 meters away from the turbine, and the vertical pinging is the ADCP measuring the current. The blue is the active sonar. Then remembering we've got hydrophones on the device recording all the noise from multiple sources. Whilst the hydrophones are actually aimed at recording device noise, the initial commissioning data analysis of the commissioning data did actually pick up what seemed to be evidence of cetacean presence, which is interesting. So in coordination then, we also have the separate, completely independently funded independent wildlife observations that we would ideally like to integrate to be able to look at that data source, identify when there are target species in the area, and then to put in place triggers that would set the active sonar and the camera off. Again, that has to be developed first. We also mentioned briefly earlier the marine radar that's up there. Some very good work being done by the National Oceanographic Centre as part of the Flowbeck project and elsewhere, looking at characterising the tidal resource and indeed turbulence that might be caused by tidal turbines as evidence through surface as surface evident through picked up just by normal marine radar. And there's some very interesting work, again, coming off of, out from the FLOBEC project on using radar to detect even flocks of birds and fins of some cetaceans. So I'd encourage people to have a look at that. And also we ran our drifting acoustic buoys periodically down through the site to get some drifting acoustic data at the same time as all the rest. So we've got multiple sources of data. With the camera in the initial deployment, the camera was actually mounted on the turbine, but in our better improved pod, we actually have the video camera, the pod itself. So again, as I said, that's the data are all coming in. The project is unfortunately doesn't include much funding for data analysis, so that is something that we're looking for at the moment. So really, as a quick summary, the evidence base is still urgently needed to aid regulatory decision making. Despite a lot of years trying to use a lot of different sensors, the monitoring of devices in situ under the water is fraught with difficulties. Data analysis really ideally needs to be automated and integrated. Automation is a real problem. It's a very significant issue. Algorithms, behavioral algorithms need to be developed to make it really useful. And even if you can get that sorted, you've still got massive problems of data volume, especially when dealing with acoustic data. And looking at fully integrated data analysis is a very complex and costly issue. And just a note, very finally, the last thing I wanted to say was that we're planning to disseminate the overall findings from the EMEC-MAG later this year. But as I've explained, there are bits of evidence, bits of useful information coming off, but I wouldn't want anyone to be disappointed by thinking that we've learned actually an awful lot more than we actually have. The challenges are still there. Data collection is still a massive problem, and sensors need further development. So that's me. Thank you very much.
Great. Thank you very much, Jennifer. That was very, very good presentation. So it looks like we're about to run out of time, but we do have some questions. And so we'll take a couple questions to wrap it up. So the issue of a potential collision of animals with turbines continues to be very challenging to investigate. Have you thought about any novel approaches I'm sorry, this is the wrong question. Let me see here. The issue of potential collision of animals with turbines continues to be very challenging to investigate, and EMEC has made an excellent contribution to the state of the science. What pathway do you see for moving forward towards almost, I guess you could say, retiring this particular risk?
Looking at retiring the risk, did you say?
Yeah, better, yeah. Better understanding the.
Well, I actually have a lot of hopes for underwater cameras myself. I think there are a lot of improvements being made to cameras. The challenge, and there's good software being developed at the moment for some of the better enabled cameras. The challenge is still going to be being able to get good enough visibility from far enough away, and also getting any coverage during the night, during the hours of darkness. So I have to say, even though using active sonar is fraught with many difficulties, I still have a lot of hopes pinned on some of the monitoring that's been done at the MAGEN site. So in case anybody isn't not aware of the MAGEN project, so that's the first commercial project that's been licensed in Scotland. Do have a look at MAGEN, that's MEYGEN. The Scottish Government is funding some of the what it considers to be essential monitoring associated with the regulation, and they are looking at different ways of gathering the device, the specific information needed using mixture of active sonar, and passive sonar, and camera information. I think they are probably planning to use the Flowbeck pod, so do have a look at that website. But we're hoping to get. I mean, I think that there are a lot of hopes being pinned on that monitoring program, which will be producing useful information in when the devices are deployed in the water. Separately, if we're looking at that's, I suppose you could say there might be a distinction between how you monitor surface seabed-mounted devices, so devices that basically sit on the seabed, compared to maybe floating devices. And we've got a project we're actually working on developing a proposal at the moment aimed at monitoring the surface devices. This is devices that are, so tidal devices whose support structures are actually floating, and then the turbines hang down below the floating structure. But as for retiring the issue, I think the aim has been all along to try and gather information at the early stage deployment sites, really to inform the level of the risk, and that still hasn't produced the necessary evidence base. So for the wee while yet, I'm afraid, I don't think it's going to be able to be retired.
Yeah. Okay, great. And to analyze displacement, have you ever performed any tagging studies with fish or marine mammals, or is it all visual observation?
At our sites, we've just done the visual observations. We've looked at the feasibility and the potential usefulness of doing tagging studies. In the past, we've had a lot of discussions with the SMRU, Sea Mammal Research Unit, and our monitoring advisory group, looking at whether we would get any useful information from tagging. We have, similar to Sarah, we have relatively low numbers of cetaceans at EMEC. And so tagging studies have been deemed by the experts to be of limited use at our sites. Personally, I think it would have been nice to have done some tagging studies, but again, whether or not we'd have had sufficient animals to give really useful data, then it would remain to be seen.
Okay. And one last question. Have you had any significant opposition to your EMEC activities?
No. We have.
Yeah.
We have. Depends what you mean by significant opposite. I mean, bearing in mind that the EMEC sites are fairly small sites, they're well-defined sites. The only amount of, I won't even say opposition, possibly antagonism that we've experienced over the years was really after the Crown Estate released a large number of test areas all up the coastline, which were seen, it gave the impression that the whole of the west coast of Orkney mainland would be inaccessible to inshore fisheries. That understandably caused objection from the fishermen. But at EMEC we've placed a lot of importance on engaging very closely with all the stakeholders, and we've spent a lot of time and effort doing that, making sure that people know what's coming along and that we take into account people's views, be they fishermen or the local ferry company or Orkney Harbours or RSPB, etc. So I think from a test site perspective, the essential lesson there is really, to make sure that you have really good stakeholder engagement and you don't just make that tokenistic saying to you and you try and address the issues that they're raising. So no, we haven't had real objections, no.
Yeah, and that makes sense considering your success over the many years. Okay, great. Well, I'm not seeing any other questions, and we've gone a bit over time, but I'd like to give a special thank you to our presenters for presenting today on this very interesting topic, and also like to thank the participants for participating in today's webinar. Just as a reminder, a recording of today's presentation as well as copies of the presentations will be posted on TETHIS, and the URL is right there. The website also has information on previous and upcoming Annex IV workshops and conference or webinars, The next Annex IV environmental webinar is currently being discussed for the topic. If you have any suggestions or ideas, please send them our way. And then for those of you who are not on the webinar mailing list, if you'd like to be, simply send an email to that email address right there, and you'll be placed on there. So again, I'd like to thank the presenters and thank you all. And